Hi, we're going to start a tutorial on laser point source classification under the ANSI standard. And this is really sort of going to be part one. And part one is we're going to be discussing the rules. Now, I'm assuming a familiarity with numerical laser hazard analysis. In the presentation, you'll see Tmax, and that is the maximum exposure duration used for calibration classification. We have T-pulse, and this is the pulse duration and is used as the Rule 1 exposure duration for repetitive pulse lasers. The MPE is the maximum permissible exposure, and the AEL is the accessible emission limit. LSO is the laser safety officer. So let's take a look at the rules, and our first stop is ANSI 3.3.1, and we're going to be looking at Class 1 and 1M. So Tmax used for Class 1 is 30,000 seconds when the wavelength is less than or greater to 700 nanometers. The LSO can designate a Class 1 for Tmax less than 30,000 if it's inherent in the specific use or design. In other words, you've got engineering controls that limit it to, say, 10 seconds. So you would then classify for Class 1 using 10 seconds. Otherwise, it's 30,000. Now, if you're greater than 700 nanometers, we'll use 100 seconds, unless, of course, it's less than 100 in specific use or design. Now, to get the Class 1 AEL, we run a hazard analysis, get our MPE based on our maximum exposure duration, Tmax. We get that MPE and we multiply it by the area of the limiting aperture that was used in the analysis. Okay. Now, the MPE for a pulse system would be either based on Tmax or T-pulse. For Class 1, the laser output has to be less than or equal to the Class 1 AEL for measurement condition 1 and 2 of Table 9. We'll be looking at the measurement conditions in Table 9 in just a minute. For Class 1M, okay, the laser output has to be less than or equal to the Class 1 AEL for measurement condition 2, and has to be is greater than the Class 1 AEL but less than the Class 3B AEL. Okay, that's 3M. So it has to be for measurement condition 2 less than the Class 1 less than or equal to the Class 1 AEL, and for condition 1 it has to be less than the Class 3B AEL but greater than the Class 1 AEL. So let's look at the rules for Class 2 and 2M. Pretty much the same thing. The only thing that's changed here is the Tmax. It's a quarter of a second. And also you'll notice this is strictly for visible. Class 2 is strictly for visible. The output for a pulsed laser, looking at Class 2, T-pulse must be less than or equal to the Class 1 AEL. So this is for pulse systems that you're looking at for Class 2. That pulse, that single pulse, has to be less than or equal to the Class 1 AEL, and that is for any pulse duration less than a quarter of a second. Class 2 AEL is found in the same manner as Class 1. You take the MPE based on a quarter of a second exposure, multiply by the area of the limiting aperture used in the calculation, and that will give you the Class 2 AEL. And we already know the Class 2 AEL from previous courses is 1 milliwatt of average power. So the Class 2 the laser output is less than the Class 2 AEL for measurement condition 1 and 2, and for 2M it is less than or equal to the Class 2 AEL for condition 2, but for condition 1 it's greater than the Class 2 AEL but less than or equal to the Class 3B AEL. Now, for 3R, if we are in a wavelength outside the visible spectrum, then the Class 3R AEL is 5 times the Class 1 AEL. If we are inside the visible spectrum, then the Class 3R AEL equals 5 times the Class 2 AEL. So that takes care of 3R. Now let's look at 3B. Outside the retinal hazard region, we have an average power limit of a half a watt, and that is for Tmax being greater than or equal to a quarter of a second. If we're less than a quarter of a second, that would be T-pulse, and we have a limit set on T-pulse of 1/8 of a joule. Inside the retinal hazard region, again, we have a half watt average power limit, but this time it's for Tmax that is greater than 0.06 times C sub A seconds, and class 3B AEL is the minimum if we're less than 0.06 times C sub A seconds. If T pulse is less than that, then we have a limit of either 0.03 times C sub A joules or an eighth of a joule, whichever is the minimum. And this is always when a half a watt of peak power is exceeded, and that makes sense. If you only have a half a watt of peak power, that means no matter how many pulses you have, you can never exceed a half watt power, the half watt 3B power limit. And no pulse, no single pulse in that train, if it doesn't get higher than a half watt, can be hazardous or considered outside the 3B AEL. Now let's take a look at wavelength dependent parameters and correction factors. This is table 6A, and what we're looking at is C sub A. So C sub A is 1 in the visible. It is 5 from 1050 to 1400. So for example, if you were looking at a YAG, C sub A would be 5. And then between the visible, 700 from 700 to 1050, we see that C sub A varies from 1 to 5 according to this equation. And really what's happening as we're moving into longer wavelengths, C sub A is driving the MPE up. Okay, so it's not as restrictive. We'll take a quick look at Table 8A, which is limiting apertures we use for hazard analysis. And I only point this out because if you're already familiar with this, then you're going to already know the measurement apertures for condition 1 in Table 9 for doing classification. And this is just a reminder, Table 8A, limiting apertures when we do a hazard analysis. Let's go ahead and look at Table 9 now. You'll see that based on the wavelength and exposure duration, we have a set of apertures and a distance to set these apertures to make measurements through, right? Okay, so condition 1, optically aided viewing. This condition sets whether a laser might be a 1M or a 2M. And of course, this is our real classification condition, condition 2, where we're close up to the laser, and this generally drives the classification. But these two together, we use both of these to determine the classification. In condition 2, you'll notice you have a measurement distance of 10 centimeters, and again, I'll remind you that these apertures are the same as the limiting apertures we use in safety. So this gives you a familiarity with the table, and based on the wavelength exposure condition, we can then set our measurement apertures up at the measurement distance and do some measurements or modeling to determine our classification. How does that exactly work? Well, it sort of works like this. Okay, you have a laser, condition 1, we set the aperture that comes from Table 9 based on wavelength and exposure duration at 200 centimeters. We measure the laser output through the aperture and compare it to the AEL. For condition 2, we do the same thing, except we set the aperture at 10 centimeters. We select the aperture from Table 9 based on wavelength and exposure duration, and we measure the laser output through the aperture and compare to the AEL. Okay, so that's the rules. That's where we want to stop. This is part 1, and we'll continue on with actual examples in the next parts to this. Okay, that's it.